that would have been my first question. What do you see on this picture? Doesn't matter. Yeah. Many people indeed would say, I see a scene of the movie Lord of the Rings, or I see the scary creature Gollum. Yeah. Personally, I have a different answer. My answer is, I see peatlands. Often you have movies where you see peatlands. They are really important, not only for movies, but I would like to take the next few minutes to explain you why peatlands are important also on a global scale. Well, to do that, I take you on a trip to the northern part of Sweden, and you see here lots of forest in the top of the picture. But here we see something else. This is a place where trees cannot grow because it's really too wet for them. And those places are peatlands. They are scattered all throughout Scandinavia. They also occur in the north of Russia and also in Canada. So they occur worldwide in the northern hemisphere. Peatlands, well, probably it's good to tell what peatlands actually are. They are nothing else than a pile of dead, rotting plant material, which actually already accumulated there since the last ice age. So it's maybe 8,000 years ago, and you see here the surface of the peatland, and beneath that there is a thick layer of about 6 meters deep, so twice the height of this room. Underneath the surface is completely full with dead, rotting material. Well, it's not only dead, rotting material, but it's also carbon. Like all organic matter, also we humans are made of organic matter and thereby of carbon. So these are important carbon stores worldwide. They occur a lot. Well, if we then zoom in on this landscape, we see one of the species that occurs there is peat moss. Well, and here you see it, that's just the background. It's really covered by peat mosses, those peatlands. And those peat mosses, they need water to survive. Well, here you can see that it is still green, and that's where the photosynthesis takes place. It's really in the top 5 centimeters, and there the peat moss fixes the carbon from the atmosphere, takes it and transfers it to living plant material. If we then go a little bit deeper, we see here that it's getting a bit yellowish and brownish, and there it is dead. And if we go even deeper, if you go to the right, well, you can't really see it that well actually, but it's really black. That's why we can see it, and that's really dense, thick carbon and large concentration of carbon in those peatlands. Well, we are, as I told, the peatlands, they are really wet, and the water tables are very shallow. So this moss has sufficient water to survive. Like all plants, it needs water to survive, right? But if we have climate change, then it will be much drier in those systems. Then the water table will drop, and also the periods between precipitation events will be longer, so between rain events. And then this moss will get problems with photosynthesizing because it has no sufficient water. If that is the case, then there's not much carbon uptake anymore in this peatland, but there's a net emission of carbon, which makes the temperature of this peatland, of the atmosphere, makes the temperature higher in the atmosphere, and as a reason of that, the climatic warming is accelerated, and the peatland is decomposed quicker. And if we continue this loop, like the worst case scenario would be that all those peatlands would be gone in future. Well, this illustrates how fine-scale eco-hydrological processes, so processes acting only in this top 5 centimeters of this peatland, how they can influence the global climate. And I hope those peatlands will still occur so we can watch those nice movies in the future. Thank you for your attention.